Student, welcome to the channel. In this video, we will solve a numerical problem from orthogonal machining that comes under manufacturing technology. The statement of the problem is in an orthogonal cutting operation, the tool has a rack angle of 8 degree. The chip thickness before the cut is 0.30 mm and the chip thickness after cutting is 0.65 mm. Orthogonal cutting means that the relationship between tool axis and workpiece axis is perpendicular, and the rack is the surface where chip is flowing after cutting. So it is the angle between the rack surface and the perpendicular drawn from the tip of the tool on horizontal direction, and it is denoted by alpha. Chip thickness before cut is 0.3 mm given in this question, and if you look upon the value of chip thickness after cutting, it is twice. Now why this is happening? This is happening due to the thermal expansion. At the time of machining, we found that the heat is generated due to friction, and this heat will taken by the chip. That's why its thickness will increase after cuttings. So generally this question is asked why the thickness of chip after cutting is increased. The right answer is due to the thermal expansion. In this problem, we can going to find out the shear plane angle, and the formula for the shear plane angle is tan phi equal to r cos alpha 1 minus r sin alpha. And second, we can going to find out the shear strain. The formula is cot phi plus tan phi minus alpha. So in every numerical solving approach in any subject, first you have to write down the given data that will help where we can start to solve the numericals. So in this problem, the given data is rack angle, that is 8 degree, chip thickness before cut, that is denoted by T1. Sometime you got it is denoted by T naught. So you cannot confuse between these terms. Then in question, the chip thickness after cutting is given and it is denoted by T2. Sometimes it is denoted by TC. So you cannot confuse with this term. Already we have seen the formula of shear plane angle, and as per the formula, we find out that the value of R is missing and the value of alpha is, that is rack angle, is given in this problem. So missing data is R, and we know what is the formula to get out the value of R. Secondly, we have to find out the shear strain, and shear strain is dependent on the shear plane angle and rack angle. So already in our problem, rack angle is given. So it is only we have to find out the shear plane angle. So we can move for the first step to find out the chip thickness ratio, and we know that the chip thickness ratio, that is denoted by a small r, is equal to T1 by T2, and the value of T1 and T2 is already provided in our question. Now you have to put this value and find out the value of R. One thing you have to remember, the value of R is always less than 1. If you got greater than 1, then you have done some mistake, or you have replaced from T2 to T1. So always you have to check the value of R. If it is less than 1, then there is no problem. Okay, now we have find out the value of R, and we know the how to find out the shear plane angle, that is phi. So as per the formula, tan phi equal to R cos alpha divided by 1 minus R sin alpha, and now we know the value of R and also we know the value of alpha. Now put this value in the provided equation, start to solve with your scientific calculator. And once you have found out the value of tan phi, but we have to find out the value of shear plane, that is phi. So you have to re replace the tan phi to the left hand side, and it is tan universe. Now you have to put it on in your scientific calculator and find the value of phi. The value of phi comes, that is 25.96 degree. Once you find out the value of phi, now you are able to find out the value of shear strain, because in shear strain only missing data is phi and alpha is already provided. Now put this value in the equation. Now there is one challenge when you are going to solve this in your scientific calculator, you will not find where is the chord. So to solve this, we know the relation chord equal to 1 by 10, and by this relation you are easily find with the help of scientific calculator. You have to solve, put in your scientific calculator. Finally we got the value of shear strain, that is 2.377. Now we find both the value of shear plane and shear strain. I hope student you find out the way how to solve this numerical easily, and this type of question is frequently asked in GATE, ES and other competitive exam. These questions are directly based on the numerical, and only challenge is to you have to remember the questions. I hope you have understand. If you understand and it will help to improve your knowledge, then you have to like, subscribe, and suggest me how to grow my channel. Thank you. Thank you for watching my YouTube video.